Hello everyone, today we are going to see class 10 second chapter polynomials. So before going to the exercise sums, we will just see a quick intro and recap about the basics about polynomial. So first we'll see the definition. A polynomial is an expression that contains variables, constants and operations. So here they have given you example 5x cube minus 4x plus 7. So it is a polynomial. First, why it is called as an expression? Because it does not have any equal to sign, right? So there is no LHS and RHS. Expression is simply denoted as there is no LHS and RHS. So I can say that it is an expression. Okay, so it contains variables. So variables are nothing but all these x. So this is a variable and this is a variable. So why we are saying that it is a variable? Because its value keeps on changing. Okay, it does not have a fixed value. Okay, so no fixed value. So it is called as variables. For example, say like x. So variables are denoted by alphabets that you already know, right? So it is denoted by alphabets. It does not have any fixed value. Whereas the constants are nothing but here. So these are constants which has fixed value. So it has fixed values. So here it has fixed values. So it is called as constants. And operations. So operations are nothing but like addition, subtraction, all these are nothing but operations, right? So now we can clearly understand that polynomial is an expression. It does not have any LHS or RHS and it contains variables, constants and operations. All these are nothing but variables, right? So these are variables. So based on this we have many types. So types of polynomial based on the terms. Okay, first we have to know what do you mean by terms. So terms are nothing but for example here itself we'll see what do you mean by terms. So I'm going to split the each operation. So before this minus sign I'm putting here a slash, right? So and before this plus sign I'm putting here a slash. So this which means, so this is my first term, this is my second term and this is my third term. Okay, so these are nothing but terms. Okay, so a part of polynomial which is separated by its operations are nothing but terms. So based on these terms we are going to categorize the polynomial. Okay, so based on these we are going to categorize. So by the name monomial we can identify that it is one. So one term. So here 3x is one term, right? So we can't in terms I have already mentioned that it is a part of polynomial which is separated by each operation. So operation is nothing but when we look after terms, operations are only subtraction and addition. Here we don't have any subtraction or addition but only multiplication. So it is not considered in the in terms concept. Okay, so I can say that it is a monomial. And here and this is also a monomial, right? So it has only one term. And for binomial it has two terms. Okay, bi is nothing but 2, it means two terms. So binomial here a binomial we have as I said only we have to consider addition and subtraction only. Addition and subtraction. So binomial two terms, for example x plus 5. So I can split, right? So before an operation I have to put an slash. Okay, so this is my first term, this is my second term. Since I have two terms it is called as binomial. And same here, this is 1 and this is 2. So since I have two terms it is binomial. And for trinomial it is 3 terms, right? So here 1, before the operations I'm putting a slash to count the number of terms. Okay, and here also, so 1 2 3, totally I have 3 terms. Okay, so this is types of polynomial based on the terms. Okay, now we are going to see before going to the next concept, we have to understand a term called degree. Degree is nothing but highest power of x. So for example, 3x to the power 4 minus 2x plus 1. They are asking us to find the degree. So as per the definition, it is the highest power of x. So I have here 1x and here another 1x. Okay, if there is no power for x, it is simply denoted as 1. So which is greater among this, 4 or 1? Obviously 4, right? So this is greater. So since 4 is greater, my degree will be 4. Okay, so it is nothing but the highest power of x. So if instead of 1, if there is 5, my degree will be 5. Okay, so this is degree. Now we will see, based on the degree, we have certain types of polynomial: constant polynomial, linear polynomial, quadratic and cubic polynomial. So based on the degree, we have all these things. Constant polynomial, it is the degree is 0. Okay, so for constant polynomial, my degree is 0. So constants are nothing but just numbers like 7, minus 3, 5. I can't write any power to some constants. So my degree will be 0. So it is constant polynomial. And linear polynomial is nothing but 1. Yes. So linear is nothing but 1, which has a degree 1. So if there is no power for x, my default power will be 1. So I can say the degree of the given polynomial is 1. And quadratic polynomial, so quadratic polynomial, here the degree is 2. Okay, why? Because here my degree is 1. So which is the degree, which is nothing but the highest power of x? So 2. So so this is a quadratic polynomial. And for cubic polynomial, it is 3. Okay, so here the same highest power, so here 1. So among this, 3 is greater, so this is my degree. Since 3, it is cubic polynomial. Okay, a easy way to remember is, for quadrilateral we will be having length and breadth. It is a two-dimensional shape, right? So since it is a two-dimensional, I can remember that my degree is 2 for quadratic polynomial. And for cubic, I have length, breadth and height. So it is a 3D dimensional shape. So my degree will be 3. It is an easy way to remember. Now moving on to next concept, which is 0 of the polynomial. So first we'll see the definition. A number is a 0 of the polynomial if substituting that number makes the value of the polynomial 0. For example, let me take px is equal to x cube. Here px is nothing but polynomial containing x variable. Okay, polynomial containing x variable. So it is nothing but what? Polynomial containing x variable is simply denoted as p of x. So p of x is equal to x minus 3. So now they are asking us to find the 0 of the polynomial. Okay, so 0 of the polynomial means we have to substitute any value in the place of x to make this particular expression 0. So in place of x, if I substitute 3 minus 3, I'll be getting 0. So I can say that 3 is the 0 of the polynomial. Why? Because if I substitute 3, it makes the whole expression as 0. If I substitute 5, what happens? 5 minus 3 is equal to 2. So it is not equal to 0, right? So it is not a 0 of the polynomial. But 3 is a 0 of the polynomial because it makes the expression 0. Clear? So next, value of a polynomial. So value is nothing but we have to just substitute any number for x. So here I have said, right. So this is 2. So this is nothing but the value of the polynomial, value of p of x. right? So this is not a 0 but a value of p of x. So just we have to substitute any number. If the p of x is this, I'm just they're asking us to find p of 2, which is nothing but in the place of x we have to substitute the value 2. Okay, so p of 2 is equal to 2 into 2 square plus 2. So 2 square is 4 and 4 into 2 8, 8 plus 2 is 10. So 10 is the value of p of x. But 10 is not the 0 of the polynomial. Sorry, but 2 is not the 0 of the polynomial, right? Because but 2 is not the 0 of the polynomial because it doesn't make the expression as 0. Okay, so if they ask the value, it is nothing but we have to substitute any number. So whatever the answer you are getting, it is the value of p of x. Clear? So next we are going to see a concept called parabola. So it is in your first exercise. So parabola, it is a shape of quadratic polynomial. So parabola will be in this shape or in this shape. Okay, so these are parabola. It is a u-shaped graph. Okay, so this is my general expression for a quadratic polynomial. General expression for a quadratic polynomial. Okay, so quadratic polynomial means what? The degree is equal to 2, right? So here my degree is 2, so I can say that it is a quadratic polynomial. So if I plot a quadratic polynomial, I'll be getting a parabola. Okay, so the shapes are nothing but, yes, so the upward open is nothing but the upward parabola and downward open is this. Okay, so for example, this is your given equation. So a is nothing but the coefficient of x square term. Okay, a is the coefficient of x square term. If a is greater than 0, then your parabola will be in upward. If the coefficient of x square, which is a, is less than 0, then the parabola will be downward. Okay, so this will be useful for your 1 mark, so that I have given you. In exercise 1.1, sorry, in exercise 2.1 we'll be seeing about parabola in detail. Okay, so that's it for introduction for chapter 2. Okay, thank you.